All right, in this video, I'm going to be giving you the proof of the power rule, right? The power rule, one of our simplest derivative rules, where we can take the derivative of, x to the nth power by bringing that nth power down around the front and reducing the power by 1. All right, so like I said, the theorem is that the derivative of x to the n is n times x to the n minus 1. But it's important for me to note, this proof is only valid for n being a natural number. It's true for n being any real number, and I will have to come back later once we know how to take a derivative implicitly to show you, the rest of the powers. All right, so first I got to remind you the definition of the derivative is that the derivative is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, so let's just bring in that limit, apply this limit to x to the nth power. And so what we're going to do is we're going to take f of x plus h, which in this case is going to be x plus h to the nth power. We're going to subtract f of x, which is x to the n, and we're going to divide by h. And we're going to be interested in what happens to this fraction as h goes towards 0. Now, what I'm going to have to do, just to take something like x plus h to the nth power, where n is some, unknown natural number, we're going to have to use the binomial theorem, which you likely studied in Algebra 2 or pre-calculus. You might have had to do the Pascal triangle or something, but I'll just bring in the theorem to remind you of how that worked. So the binomial theorem stated that if you wanted to take x plus h to the nth power, what you would have to do is you would take basically the sum over I of n choose I, x to the n minus I power. So basically x is starting with all n powers, and then it's decreasing each term, and h is starting at, the power of h is starting at 0 and then increasing, right? You start with x to the n, and then x to the n minus 1, h to the first, x to the n minus 2, h to the second, all the way up until you get to the point where you're taking x to the 0 power and h to the n power. Now, it's important at this point for me to note a couple of things. That n choose I is the number of ways you can choose a group of I out of n total choices. Okay, so n choose 0, well, if I have, 5 people and I need to choose 0 of them for, a group project or something, there's only one way I can do that, and that's by choosing none of them. So n choose 0 is always 1, and n choose 1, okay, if I have a group of 30 and I need to choose, say, my favorite student, well, there's 30 different ways I could choose. I could choose any of the 30. So n choose 1 is going to be n. The rest of them are not going to be important for reasons that you will see as time goes on. I'm realizing that this thing over here didn't really look like an H, so I'm trying to make it look more like an H than like an N. Okay, so with that knowledge, I'm going to kind of clear out some of the binomial theorem and, write down what we need. All right, so I cleared out the n choose 0 because I don't need that anymore. And I replaced n choose 1 with n. Okay, so what this limit is going to equal now is going to be the limit as h goes to 0 of x to the nth power plus n times x to the n minus first power multiplied by h to the first power. Then n choose 2, x to the n minus 2, h to the 2. Each term after that is going to have a higher and higher power of h. And the important thing about these terms, I've just kind of put them in as a ... is that they all have more than one power of h in them. Okay? And then I'm subtracting x to the n and divided by h. Well, what I'm going to point out is that I have the first and last terms are x to the n minus x to the n. So those are going to go away. Okay? And then meanwhile, I might also say I'm going to end up factoring out 1 power of h from all of the rest of the terms, right? So that I can eventually cancel with that h. Okay. Now that's, I'm going to bring in the next line of this equation, but that's basically what I'm doing. I'm subtracting x to the n minus x to the n. I'm going to factor out that 1 power of h. And so there I did it. I canceled off the x to the n's, and I factored out the power of h. So now what I'm left with, okay, see that nx to the n minus 1 multiplied by h, that no longer has an h associated with it. And so what we're going to do is we're going to cancel h divided by h, because that's 1 for every h, right? Except for h equals 0. But we're considering what happens for values nearby 0. Then I'm going to have n choose 2, x to the n minus 2 times h. And you know what else I might do? I might actually show you what the next term of this thing looks like. Right? I could say that the next one would be n choose 3, x to the n minus 3 times h to the 2. Okay, after I factored out that one h. And then there will be, you know, all the rest of the terms up to the point where we're taking x to the 0th power and h to the nth power. But and what's important is that there's more than one power of h, so that when I cancel off these h's, oh, whoops, what I'm left with is a bunch of things that have, okay, I'm going to highlight maybe in orange all the things that have an h in them, because as h goes to 0, anything with an h in it is also going to go to 0. So we're letting h go to 0, and so this is an h, and so that whole thing will go to 0. This has got an h squared, so again, the whole thing goes to 0. And all the rest of them, because they originally had more than one power of h, they all still have at least one power of h left after I factored it out. They're all going to 0. So what I'm left with is just this nx to the n minus 1, which is what I set out to show in the first place. Okay? So that's the proof of the power rule for n being a natural number.